all the homework questions, if you are just interested in seeing what's the correct way to do it, yeah, look at the homework help video. That'll tell you the correct way to do it. Now, I will freely admit to the limited utility of having the solution available. And it's not just about, people just copying from the answer key, which is always a concern. But, I'm less concerned about that now that I rely on the required one-on-one meeting, because my grading is basically based on can you solve physics problems. And if somehow copying from answer key helps you learn how to solve physics problems, hey, go nuts. But from my experience, I don't think that actually helps you learn physics. Even watching my video, trying to follow it, if you just did that and stopped there, you will probably forget most of it next time you come back to it. Really, what will help you learn how to solve physics is doing it. Really, nothing beats actually doing the physics problems. So what I'd like to do is do something that, oh, wait, well, let me clear this. Okay, I think those I need to mark as done. So these I don't even need to actually view. These two I need to mark as done. I've mentioned the test student is my worst student, right? It's never does anything he doesn't have to. I thought I viewed that page. Oh. Good. So I will go through working through the homework questions, and just so that it's more realistic, it's not, someone who already knows all the physics material working through it. I'm going to pretend that I don't know certain things, and as a demonstration of what you could do if you are putting in effort, working through physics problems, getting frustrated. That's actually an important part of learning. I think at the beginning of the semester, I spent some time, guessing your name wrong. And it's really embarrassing when I do that. And that embarrassment is part of learning. That's the only way I've been able to memorize people's names semester over semester. So what I would suggest to you is that as frustrating as it can be, you should try working through these questions. And one tool that you now have that you really didn't have a year ago even, because a year ago it wasn't as good. You can have a virtual tutor right next to you as you are working through. Because if you're working on it during my office hour, Monday, Tuesday evening, then great. I'm here to answer your question right away. But otherwise, you send me a message. And even though I do try to answer quickly, within a few hours, unless you are messaging me like at 10 p.m. on a Monday night, then I will wait until next day morning. There's some delay, and that delay might be the reason you don't ask the question. ChatGPT, as a virtual tutor, will respond to you immediately. And it's gotten really good over the last year. And there are certain types of questions it doesn't do well. I think last time I demonstrated how it can't really help you draw free body diagram. So when it comes to free body diagram, you will have to rely on verbal description of diagram from ChatGPT and just draw it yourself. And basically, what I've found is that any question that involves geometric reasoning, I think ChatGPT struggles. Maybe because it's a large language model. A lot of the tokens it's relying on is, language. So there are certain places here and there that ChatGPT will struggle, but a lot of times it'll give you great advice on a usual way to tackle a question, and so that's the thing that you can have available, and that's what I will have side by side to use as a kind of a demonstration over the next 30, 40 minutes, just showing how this tool, ChatGPT, can help you kind of work through points of frustration that will naturally come up as you work through the homework set. So this time, let me actually start out with this prompt. I've demonstrated this a few times. If you don't prompt ChatGPT in this way, it'll just give you the answer right away, in which case, you don't need ChatGPT for that. You already have my homework help videos. If all you wanted to do was to look up answers, hey, you already have that video. You don't even need the ChatGPT. So I gotta tell it, hi, I'm back, ready to work on my mechanics university physics problems. I know we are in college, but university physics is code for calculus-based engineering physics. University physics problems. And like before, I really need to make sure that I will learn and remember how to do these questions. Learn and remember how to do these questions. Sorry, I got distracted in my head with something else because I need to be able to do these questions again in front of my instructor at a required in-person one-on-one meeting. I can't have you at that meeting. Let me paste in the questions, maybe explain some of my reasoning process, and I really want you to help me learn by not giving me the full answer right away. Maybe just the immediate next step if it looks like I'm struggling. Would you do that for me? Now, I've been told that with the more recent models like ChatGPT o1 and o3, that apparently you are not supposed to use the long boomer prompts anymore. I think this is fine. This is setting the stage. I'm not, telling ChatGPT you are, smartest being there is. Like, I think that's the boomer prompt. I've never done it. So, so let me find I think if I work on substantive questions, we probably have enough time for 2 or 3 questions with all the, mistakes that I'll be making. So let me find the 2 or 3 substantive questions to do here. Like this doesn't feel substantive. There might be a substantive question in this group. So this would be substantive, except I think you already did it as part of the lab. And so I don't feel like I need to do it again. So let me skip it. This I think is surprisingly easy question. At first, or although I might come back to it. I think the one of the more substantive questions is whenever whenever involves interaction, more than one block is where there are more opportunities for mistakes. So these questions 3 and 4 blocks on an inclined plane, even though they are kind of almost a standard strategy question involving forces in 2 dimensions. I think they're kind of on the easy side. So maybe nothing from the first 5 questions. I think that must have been the breakdown, how I organized this set. So this next set of questions is where, no, this is the centripetal force. Maybe, let's do this. So there are certain common points of confusion, and I believe there are some of these that ChatGPT was not doing so well before. I want to see if it does well. So this is the kind of question that, in one sense, it's simple. So, for example, I think I might even remember the formula for the answer here. So this is the formula that I think I remember seeing my students use and just being super annoyed that they were using it. I think theta is arctangent of R V over G is what I think I remember students using. Am I right? Um, no. Think V squared over RG. I think that's right. let's just give it a try to see if I memorize the formula correctly. Um, so let me use Wolfram alpha. So arctangent of v squared, 101 kilometer per hour squared divided by the radius, 1.4 kilometer times g, 9.8 meter per second squared. So I'll say 3.28. And if I remember the formula right, then it'll say that's correct. Yeah. So, so two reasons I'm saying I'm annoyed when I see this. One, especially if you get this as your problem set assessment question and you attach this as your work, you're not giving me full work. I'm not going to give you full credit because this is not the kind of formula that I expect people to have memorized. So for formulas like that that I'm not expecting people to have memorized, you really need to cite it. You need to either cite it, by the textbook question, the equation number, or you have to be able to redrive it. And suppose you're that rare person who actually has this memorized. By the way, I actually don't have it memorized. That's why I was putting R in the wrong place first. What I was doing was basically was do a bit of like a mini derivation and sanity check. I was using dimensional analysis. I knew the answer would depend on these quantities, and this is basically the only way to combine them in a way it's unitless, so that I can use an inverse trig function to get an angle. And I just happened to remember that arctangent was involved. And so it's either this or the reciprocal, one or the other. And I think the v squared one looked more familiar. So I'm not that rare person who actually has this memorized. But even if you are that person who has this memorized, if you can't redrive it, then you still don't know how to solve physics problems. You only have it memorized because someone else did it and told you that this is the answer at some point in distant past. So you really need to be able to do this in a completely new situation where you haven't seen it before. So let me lead the interaction with the ChatGPT this way. I will say, so I got this question right with this formula I looked up. Arctan v squared over Rg. But I just overheard my instructor say that he'll get annoyed if he sees us using it. What do I do? So this particular hypothetical person is more lost than usual. Last time I at least started with the 4 steps of standard strategy. But let's imagine that you've never watched my lectures. You don't know the 4 steps of standard strategy. You're just completely lost. Let's see how ChatGPT helps a person like that. So it says, handle ready to derive. Yeah. In front of your instructor. Yeah. Minus start. Yeah, that's really the thing to do, and that's why it's the first step of standard strategy. By the way, I got a little bit of software glitch right now. It looks like for whatever reason my Zoom annotations don't have always on top feature right now. So I'm gonna arrange my screen in a way so that I'm writing on the I'm writing more on the kind of the black background so that my writings don't constantly get obscured by other windows that have higher priority than my Zoom annotations. It's annoying, but no better way to handle it than what I'm doing right now, I think. So I'm gonna get to it, but let's go through the steps following the hints that ChatGPT is giving. Let me use a light pen on black background. So draw a free body diagram. What is it saying? On the banked surface, neglecting friction, label the forces, then see how they balance in both the horizontal and vertical directions. That's the typical route. So let's again, since I'm role playing a student who's particularly lost, let me imagine I'm someone who doesn't know how to draw correct free body diagrams in situations like this. So someone like that might draw. Maybe you remember, oh, there's always gravity, so you draw gravity, and then maybe you think ma, the acceleration, Newton's second law, and then like that's where you are. You don't know any other forces. Uh, let, and nice thing about ChatGPT is that it's able to list all the forces you should be considering and actually walk you through the description of those forces. Now, as I was saying before, it won't be able to draw a free body diagram for you. It's one limitation of ChatGPT that I do hope will get fixed at some point because it's a really glaring lack of ability for artificial general intelligence. So I'll say, I'm so lost. Does this free body diagram look anywhere close? And it'll say you're missing some things. ChatGPT is usually really polite, so it won't tell you, I can see why you are so lost. Like, it won't be mean to you. It'll say that's a start. Yeah, for a bank turn, you want to make sure you include the normal force from the road, which points away at an angle to the vertical. Yeah. And I think at this point, you should, so hopefully, no one's so lost that, that that you do know some idea of what banked means. But let me imagine someone, maybe English is your second language, and you have no idea what's meant by banking angle. So, um, what does banked mean in for a banked term? Or I guess banking angle from the question text. So, sometimes we tend to ask you questions assuming you know certain things. So we might assume that you completely understand what banking angle means. You're not confusing with the financial institution. You're not confusing with the water infrastructure that but if we are wrong in assuming that, ChatGPT is great in giving you a kind of just-in-time clarification. Like, what does a bank mean? When it feels like whatever people question or ChatGPT was saying, if it doesn't make sense to you, then ask. It'll clarify. 40 minutes. Yeah, it's gonna be good. Banked means, yeah, roadways tilted or sloped, that there's an angle from the horizontal by some angle. And as you read these descriptions, hopefully as a thinking human being with a reasonable level of English proficiency, you can understand, that's what it means. So there's a kind of a sloped surface, an inclined plane that you need to be imagined. You need to be imagining. So that's the banked angle there. So with that understanding, let's go back up. So it was describing a normal force for me. It said point away from the surface. This is the surface. And when I point away, draw the normal force perpendicular to the surface away. So let me just erase this now because it's going to be annoying to erase it later. So I need to draw this normal force here. It's pointing away from the surface, perpendicular, not straight up, but tilted at the banking angle. That let me attempt this in good faith and not going to tangent to misinterpreting this description. Draw weight straight down. I've already done that. Once you have that, then we can break n into horizontal and vertical components and see how they balance out to provide the centripetal force horizontally, balance the weight vertically. That's how you, okay. So let me do two things at the same time. So one is to just check, does my free body diagram look right? This time it should say yes. I have two questions. One, does my free body diagram look right now? Attached. And the second question, you said to break down N. But I've seen my instructor break down the gravity mg when it involves inclined planes like this. Are you sure I'm supposed to be breaking down N? It is a common mistake, especially among people who only superficially understood the Newton's law problem solving strategies. Because you do it kind of on a loose pattern matching. You're used to saying, "Oh, I see an incline," then it means it goes something like this. You got an acceleration. You break this down. Like this is something you would have seen many times, so you kind of go immediately to that. That's actually wrong for this question, and hopefully ChatGPT explains that in detail. Yes, the diagram looks right. Great. It's totally up to your coordinate choices. However, most people keep the vertical axis straight up. Uh, Now, does it explain? Um, so I think as you read this, if you want to continue on the line of reasoning I was confused on, you can do this, or I can do this anyway. So I drew my axis the usual way to draw them for inclined plane questions, and I can say, oh, I think I know where you're coming from. But most inclined plane problems I've seen, I saw the axis defined this way. So can I do it same here, same way here? This is really what I'm used to. And I don't want to do it the other way, even though the other way is better. I want ChatGPT to explain why the straight axis is better here, based on the direction of acceleration. I don't want it to give up and let me just use this axis because it's really the worst choice. Then you have to write down the horizontal. You have to write down x and y components of acceleration. That's really bad. You can choose it that way, but for easier, if you choose the center of the curve, why is that easier here? Because the motion is motion is horizontal. So if as you hear this, you understand this setup. So I think when I do questions like this, I usually draw a top view, and I explain, for a roadway that bends like this. If you are a car over here, and this is the center of that circle, then your centripetal acceleration is, well, right, freehanding. Your centripetal acceleration is pointed this way. So, and you imagine kind of, in three-dimensional space from the back view that this acceleration is pointed that way. So if you can imagine that, great spatial reasoning that hopefully makes all sense. But let's say I'm still having difficulty with it, and I'll say, you said the motion is horizontal, circular. I don't get it. Isn't the car accelerating down the ramp? I am being difficult. Let's see how well it addresses it. On a typical, you do slide downhill for a bank turn. It's at the right speed. Neither slips down the slope nor up the slope. Yeah, movement in this direction is not happening. All of the net force is horizontal pointing. Okay. So this might, that's basically verbal description of this. Let me do one last thing. Oh, I forgot that it's supposed to be ideal banking angle. So we have acceleration 0, right? That's another mistake someone could make. Which, if you made this mistake, then there's not much you can do here. With these two forces, you can't make the acceleration zero. So, but that's a possible mistake someone could make. And let's see what ChatGPT will do with that. Not quite. Car is still turning. Demonstrates centripetal acceleration. Yeah. In the way it's described in the lecture. So whenever you see circular motion, think acceleration. Circular motion, if it has non-zero velocity, has to involve centripetal acceleration. So, what are doing? Acceleration along the slope, yeah. Acceleration towards the center, yeah. So once you have that, let's say, and really the nice thing about ChatGPT is that it's infinitely patient to tutor. And, I like to think I have gotten a lot better over my 10 plus years of teaching. Sorry, not 10 plus, 16 plus years of teaching. I'm coming up on 20 soon. Uh, uh, I'm a lot more patient now than I was in 2006. And I'm still a human being, not infinitely patient. ChatGPT will never snap at you. So if something doesn't make sense to you as you are working through, ask. Like it's literally trained to not to snap at people. Because when they rate the responses like on artificial intelligence, not being perfectly obedient to its human masters won't be rated high. So, so after asking all those questions that might have confused you, when you finally get that acceleration is indeed horizontal, and you should set your axis along that direction, then do that, x and y. Then you should see that you are breaking down n this way. And I guess at this point, in the interest of time, let me not continue making mistakes. You should go through geometry exercise. So one exercise I could go through is, because this is the goal. You have this right triangle with the hypotenuse being your vector. And it's a question of, you got these two angles, 1 and 2. It's really a question of which of these two angles is theta. One of those should end up being theta. It's either 1 or 2. And if you are just guessing, you'll be right half the time. And I want you to I want you to be right 100% of the time. And that's really a geometry exercise. What I would recommend is draw maybe auxiliary figures. So here, let me just blow this up so that I can draw the figures a little more easily. So yeah, I think I can make it smaller later. So I just keep tracking, okay, what other angles are same as this? I got these two parallel lines. So these are like alternating angle or something, so they should be the same. It's still not one of those two interior angles. Now this is right next to this angle, and they must add up to 90 degrees. So I can say this angle is 90 degrees minus theta, which means this angle this angle not being theta, so that the other angle must be theta 1. Or you can write this as 90 degrees minus this, and 90s will cancel out and you'll get theta. So that geometry exercise, I hope one day, it becomes so routine, like automatic, that it becomes tedious for you. Great, that's the goal I'm hoping for everyone. Until it's, this geometry exercise is tedious, my recommendation is, keep doing this geometry exercise until it becomes a routine that you can literally do it in your sleep. Like when you do it in your dream, you do it correctly. Like that's the goal. So with the theta correctly identified there, then that should give you enough information to identify this as an cosine theta, adjacent side, and this as an sine theta, opposite side. So, alright, so I've done the defining axis, breaking down into components. It was way up here. Let's see. Yeah, I think original break into components, see how they balance out to provide the centripetal force horizontally and balance the weight vertically. So, okay, I think I got the axis and the break down into components. How do I do this? Oh, and let me just paste this in as a kind of verification. I don't know, the drawing is becoming a little bit busy, so I don't know if it can parse it correctly, but so as you know, this goes down to Newton's second law, but I'm play acting someone who's so lost that I can't remember Newton's second law. So yeah, so it's gonna give you all the steps. I've labeled the components. Yeah, Newton's second law in each direction. Horizontal must be that. Yeah, vertical they should be 0. Yeah, and I think it's actually done this for you. And you know, at some point, if you keep pestering it with the questions, it'll eventually give you the answer. In some, depending on how you look at it, another one of its good qualities. And what I'm telling you is that the frustration that you go through trying to do this on your own, not immediately getting to this answer, that helps you. If nothing else, that should help you remember these steps better. If not the first time, then doing it again the second time will help you better. So for right now, I'm just going to copy this, and sine theta is equal to mv squared over r. This is equal to mg, and let's just in the interest of time, let me just suddenly start remembering how to do algebra. I'll solve one of the equations for n. So n is equal to mg divided by cosine theta, and I'll plug that into the second equation. Then I end up with mg sine theta over cosine, let me just write it out. Sine theta over cosine theta is equal to the right hand side, mv squared over r, and then so m's cancel out, divided by g. Let me do it in different color. So g's cancel out here. This is tangent theta, so I can say arc tan. I will say arc tan theta, and you know, for derivation like oops, wrong thing. Theta is equal. Oops. Let me erase this. Theta is equal to arctan. For derivations like this, once you do it, then you can probably say, oh yeah, that looks right. So you might not have to ask. But let's say it's another question where you can't, you know, you need someone to tell you, did you do it right? Oftentimes, the ChatGPT can give you that feedback. So, all right, I think I got it. I did the rest of the algebra. Does this look right? Yeah, it says that. Yeah, that, so. All right, we got maybe a little less than 20 minutes. Let me do this. I think I want to do. I want to do a question that involves multiple objects. So the only question I see so far is this one, or sorry, this one. But you've already done this in lab, so I don't know if it's giving you anything for me to do this again, especially taking a long time with the ChatGPT. So let me just do this quickly, just to demonstrate, you know, people who memorize the formulas can do things quickly, but that doesn't mean they are doing well. So 1.1 divided by 5.3 times 9.8, 2.03. I think that's right. Yeah, tension in the rope is so this thing times 4.2. I can't do that in my head. 8.54. Plug it to the speed. So I already have acceleration. So it's gonna be square root of 2 times 1.3 times 2.03. So I'm doing this to tell you this. One, if you do this for your not timed assessment, the problem set assessment where you're supposed to attach your work, you're going to get 3 out of 5. The system might give you 5 out of 5, but I'm going to give you 3 out of 5 because no work means incomplete. And so I guess in the required one-on-one meeting, something like this won't quite happen because I will ask you the in-between questions. Like, if you stare at this question for a while, type into calculator for a while, and then tell me, oh, acceleration 2.03, then I will ask you follow-up questions. So I think in the required one-on-one meeting, this exactly won't happen. But I guess if we imagine a hypothetical scenario where I can't interact, I can't change what it is you're doing, if I see something like this, I'm gonna get super annoyed. Because, I mean, if you can do it in your head, great. This is an easy question. Doing easy question in your head doesn't prove anything. What I'd like to see from students is a demonstration that you know what steps to follow. Because that's what matters when you have a hard question to tackle. Because the steps that we teach, the standard strategy, it's really meant to assist you with the harder questions. The kind of questions where you don't immediately know what to do. Like a question like here, I know immediately what to do. I do, so force constant, that's, so the force is kx. I'm given x. So once I figure out the force it's balancing, then it's that force divided by x. So the force it's balancing is going to be mg sine theta. So 30 kilogram times 9.8 meter per second squared times a sine of 60 degrees divided by 3.6 centimeter. Again, can someone with sufficient knowledge of physics do this in like a minute or two in their head and a calculator? Sure. Again, if I see that, I'm gonna get super annoyed. And if I soon get a multi-block question, I'm also gonna get super annoyed. It's possible. Does it not have a multi-block question for me to use? Perfectly smooth. I mean, I might. Can I? No, I can't do this in my head. Yeah, because dividing by square root of 2, I don't think I can quite do this in my head. Ramp applies a force of. So for this special angle, special question, I can do this, and I think it'll still be right. Do I need to be? Oh, actually, B is a fairly substantial question. So let's say you are the kind of student who's been doing what I was doing, the stare at a question for a while, type some numbers into calculator, boom, you're done. It's a really bad problem-solving habit to develop. I really don't recommend it. This is me, telling you, breaking the rules that I'm telling you not to break because I've gone through all this. I've earned the right to break the rules. Now, if you've been doing approaching physics problem this way, once you get to a question like this, that could stump you. So let me place myself in that situation. This is not quite multi-block question, but I think it's enough where I can imagine someone who's been, rushing through questions, now suddenly feeling like, oh, what do I do here? I don't know what to do. So let's do that. So let me actually try an answer. So you are so used to just guessing an answer, so you even guess an answer of this. Which could it be right? I haven't ruled it out. Maybe it's right. Oh damn, that's right. Oh that's bad. It's this 45-degree angle. I'm pretty sure if it's not 45 degrees, then this wouldn't work. I can't. I wish I could just refresh this and not. Let me see if I can get the same question back. Because This could be a good question to do, but let me just get the same question back. Hopefully without the 45 degree. I'm pretty sure the angle is randomized. So, okay. I think yeah, 40 degree angle. Great. So I can do the same thing before, which is the acceleration is 1.0 kilogram times 9 meter per second square times, acceleration itself is, done with that, sine of 40 degrees. And for the first part, it really should be cosine. That's why, with a 45 degree angle, either actually gave the right answer because, cosine versus sine does no change. So 7.5 Newton. And I'm hoping when I use the same number here that will be wrong. I haven't again ruled it out, so maybe it won't be wrong. What happened? Let me just remember 6.3, 7.5. I don't know why my session expired. Well, let me go to that question and I can resume. I think that's which question was I regenerating? Crazy. Okay, this one. Hex 6.4, was that the number? Maybe, I'm not sure. 6.3. Yeah, good. So now we do this. We roll the numbers where it's doing the proper demonstration that I want you to do. Let me, for the remaining, I don't know, 6 or 7 minutes, act someone who so far have been able to just solve the questions by staring at it for a while, and then now you are stuck here because you haven't been developing the systematic approach to problem solving. Once you can immediately guess at the answer just from staring at it for a while, you're stuck. Like, what do you do? And I believe ChatGPT can help you there. So the rest. Thank you. Just wrapping up the previous thread. The rest of the questions have been really easy, but it says part B is incorrect. I want to file an errata, and I'm not sure what to put in the errata. Errata is, if you do find a mistake in any question coding, just, do message instructor, send me a message, I'll take a look at it. A lot of the errors have been found and fixed in the past. So ChatGPT might tell me, oh, yeah, it's not wrong that 7.5 is not the correct answer. It's possible it's going to be mg sine theta without actually working through. I actually don't know because I don't have the answers memorized. The easiest questions I can do the derivation in my head. Now, this is not the easiest question. I actually need to draw the free body diagram, actually go through a version of the standard strategy. Some of it I might be able to do in my head, but not always, especially if it involves drawing diagrams. Yeah, it doesn't look like it's in error. That's right. It's asking for along and parallel to the ramp. I misunderstood the question. It's not very interesting. Yeah, that actually makes sense why mg sine theta was correct. Sorry. Just so the whole thing isn't in my head. I misread the question. I misread it as the kind of question where yeah, try the what it's asking about is it's asking for this force. And if I were, doodling, drawing question, then I would have realized that. But because I wasn't doing that, in my head, what was in my head was this question, like, what force would you push the ramp with so that this doesn't slide down? That's the actual interesting question. But yeah, that's sorry, a bit of a letdown. One of the lecture videos actually, I do this version of the question. Well, because it is a bit of a harder question, I don't think any of your homework questions are this. I will recommend you watch the lecture, give that a try. For the purpose of this interaction, yeah, I think, uh, yeah, yeah. So I'll say, yeah. So let's just wrap up. So 6.3 Newton. Oh yeah, because it's 1 kilogram, I think. So this acceleration is just same number. Just that way. Yeah, yeah. So I'll say, so, um, so yeah, I got it. Thanks. And then I'll just see a version of uh, what ChatGPT would suggest if it were different question. So thanks. So by the way, how would you solve it if there was an extra part that asked a different question instead of applying force on block directly? This time the ramp can move as M, and they want to apply a horizontal force F on the ramp so that the block M doesn't slide down or slide up. Um, Someone post this scenario, and I'm not sure where to start either. We won't have time to actually work through. Let me just see if ChatGPT is in the same kind of, in not same, in the correct path to answering this. The key part is realizing that this is a horizontal acceleration, and then following the standard strategy. The block's point of view, the block net force on the block, and then no. Oh, I mean, yeah, that is one way you can do, and I guess it's not wrong per se. And in some sense, it might be easier way to do it. I think I have a lecture this week explaining why we stick to inertial reference frames for our analysis, especially for rotating frames. Here, it's not my preference, but I guess it's not wrong. It'll give you the right answer. So when you draw a free body diagram here, the diagram you end up drawing will look like this again. It's not my preference, but I guess I can't stop you from doing it. So mg, normal force n, and you would be basically introducing this fictitious force, ma. Again, I would never do this in a straightforward lecture. But ChatGPT is suggesting this, and it'll give you the right answer. Just say, all right, I think I can do that. What if I want you to analyze this in inertial reference frame? Then really, the change is actually not that dramatic. All that is you get rid of this because there's no force that's ma. Ma is the net force. So what you recognize is, oh, it's gonna be accelerating that way, and you will have net force. That's gonna be equal to mass times acceleration. Like it's it's a like if you wrote down the algebra, it's just moving a term over. But I think it's mostly on the conceptual ground that I really want you to have a practice analyzing things in inertial reference frame instead of resorting to fictitious forces. Constraint, draw separate free body diagram for these. Yeah, for the block. Yeah. Yeah, in fact, the previous approach, if you just did this, I think you still won't get to F right away. You still have to do the stuff with the block M. Maybe, or No, I think even this would be kind of, there are multiple steps here that you need to fill in. So this is now more like a standard strategy where it's a one systematic approach that includes everything. Yeah, for the block, you have two real forces. For the wedge, you have this. Yeah, you have this reaction force. In the inertial frame, then must accelerate in a way they are remain stuck. Yeah. Yeah. So yeah, this is the systematic approach that if you follow, you can handle new situations you haven't seen before, and one where it's complex enough that simply staring at the question one, you'll answer right away. So yeah. So let me leave that for you for anyone interested. I think I'm gonna sign off here. Thank you so much to everyone joining, both of those joining by recorded video and those who are here in real time. Let me say goodbye to people joining by recorded video, by which I'm gonna stop the recording. And I'll stay online briefly in case people who are here in real time had any questions. So bye to people joining by recorded video.